It's chemistry and you are watching Chem Science.
In this video, we'll be discussing the A-Levels Chemistry paper, question paper 5-2, and for the year winter 21. We will be discussing only question 1 in this video. Question 2 will be discussed in the next video. And along with this question, we will be also seeing that what are the different variables which are considered during planning an experiment, what measurements should be taken and what care to be taken while planning about the measurements of an experiment, and what are the errors which can occur during the experiments and what accuracies we can consider while conducting an experiment. All this in question paper 5-2 of the year winter 21 question 1. Let's go ahead with question 1 of this paper. So here is the question 1 of this paper 5-2 of winter 21 paper, but during the paper discussion we will be also seeing what are the important points to be taken care, what are the tips to write the best answer in this paper so as to get the full score or to get full marks for a particular question. So let's go ahead. The question 1 says it is possible to measure the enthalpy change of combustion, that is delta Hc, of ethanol using the following apparatus. And you can see here the experimental setup of an experiment. Here this is a setup to consider or to calculate the enthalpy change of combustion of ethanol. So the procedure here is also described where it says a student carries out an experiment to determine the value of delta Hc, that is the enthalpy of combustion of ethanol, using the following instructions. Now you must have seen the diagram here. There is a beaker of water with a thermometer here dipped in to measure the temperature, and there is a spirit burner here containing ethanol and a wick and wooden block and a lid and the stand for all setup. Now here you can see it's a metal can, not a beaker, glass beaker. It's a metal can, so it can conduct the heat very easily. Now let's go ahead with the steps. What are the different steps which are there for the experiment? It says weigh the spirit burner with ethanol and lid and record the starting mass of 2 decimal places. Measure 100 centimeter cube of water and place it into the metal can. Place a thermometer with 0.1 degree Celsius graduations into the water and stir it and wait for 2 minutes. Record the temperature of the water. Light the wick and allow the flame to heat the water. Continue to stir the water using thermometer. After the temperature has risen by approximately 20 degrees Celsius, place the lid on the flame to extinguish it. Record the maximum temperature of the water and weigh the spirit burner and record the final mass. Now this is the whole procedure which was done by a student to calculate the delta Hc, that is the enthalpy of combustion of ethanol. You can again pause the video and reread the whole procedure. Let's go ahead with our next part of the question where we are supposed to record out something. Here you can see a table where the initial temperature of the water is noted, that is 18.1 degrees Celsius. Maximum temperature after it was heated with the help of a spirit burner containing ethanol, the maximum temperature was 38.2 degrees Celsius. We are supposed to find the change in the temperature of the water. Initial mass of the spirit burner which was supposed to be weighed, that was 153.29 gram. Final mass after heating is 152.76 gram, and so we are supposed to find out the mass of the ethanol burnt to heat up the water to this temperature difference. So we are supposed to find out the change in the temperature. So by subtracting 38.2 minus 18.1 degrees Celsius, we'll get the temperature change, and the answer is 20.1 degrees Celsius, and the difference in the mass will give you the mass of the ethanol of the spirit burner. So the difference is 0.53 gram. That also we have obtained by subtracting these two masses of spirit burner, that is before burning, before heating the water and after heating the water. So we have completed the table as per written in the question 1. Record your answers to correct number of decimal places. Now here we need to take care about the decimal places. So what have we done? Here the temperature was given in 0.1, that is to 1 decimal place. So our answer should also carry 1 decimal place. If we hadn't got the decimal place of 0.1 in our answer, we should write 0.0 also. So suppose the difference was 20, we could have written it 20.0. Here we have got 20.1, so we have written it. And here we can see in the masses of this spirit burner, the decimal place is considered is 2 decimal place. So 153.29 and 152.76. So our answer should also be written in the 2 decimal places. So we have written 0.53 gram. Now calculate the number of moles of ethanol burnt and give your answer to 3 significant figures. Now here it's written in the question about 3 significant figures. So we are supposed to calculate our answer up to 3 significant figures. So let's calculate the moles of ethanol. But to calculate the moles of ethanol, the formula used is N is equal to M upon Mr. Mr is the molecular mass of ethanol. So we need to first calculate the molecular mass of ethanol. So let's first calculate that for C2H5OH. Now here the atomic masses, relative atomic masses of all the elements is given. So 12 into the 2, that is the relative atomic mass of carbon is 12. So 2 into 12 as we have C2. Then we have 6 hydrogen, H5 and H. So 6 into 1, because the relative atomic mass of hydrogen is 1 and relative atomic mass of oxygen is 16. So here we have 1 oxygen, so plus 16, which gives us the MR of ethanol as 46. So if we substitute that, so the mass of the ethanol used is calculated here in the table, that is 0.53 gram divided by its MR, that is 46 gram. And on division we get 0.0115 moles. We have written 0.115 as we are told to write our answers in 3 significant figures. So our answer is 0.0115 moles. So this is how we calculated the moles of the ethanol used in heating up the water to 20.1 degrees Celsius. That is, the difference is 20.1 degrees Celsius. So now let's go ahead with the next part of the question. It says, use the formula Q is equal to MC delta T to determine the energy change Q that took place during the experiment. Use Q and your answer to B to calculate the enthalpy change of combustion of ethanol to kilojoules per mole. Now include a sign in your answer. 1 centimeter cube of water has a mass of 1.00 gram and the specific heat of water, that is C, is also given 4.18 joules per gram per Kelvin. So let's substitute all these values here. Q is equal to MC delta T. Now in this question, M is the mass of the water used. Now we have seen in the earlier part of the question that 100 centimeter cube of water is used, and as we know that 1 centimeter cube of water is 1 gram, so mass ends up with 100 gram of water. Specific heat is mentioned here 4.18 that we are substituting, and the delta T, that is the temperature change, we have already calculated in our earlier part of the table, that was 20.1. So calculating all this, substituting all this value, the heat energy is 8401.8 joules. So that is the enthalpy change, that is only Q. But we need to change this heat energy into kilojoules per mole. So that means we need to divide our answer Q by the number of moles we have calculated in our part B. So here our answer of energy, heat energy, is 8401.8 and the moles calculated earlier were 0.01115 moles. So for this our answer is minus 731,000. Now if we are converting it into kilojoules per mole, so again we need to divide it by 1000. So our answer is minus 731 kilojoules per mole. Now we have included answer minus. Now reason here being is that there is a increase in the temperature. So here the energy change should be negative because the enthalpy of combustion of any substance is always exothermic. So our answer should include a negative sign. So here we have included a negative sign because of the increasing temperature of an exothermic reaction. Now next part of the question says calculate the percentage error of the temperature change recorded in the table in A. Now temperature change, as we had already seen, was 20.1 degrees Celsius. Now show your working. It says calculate the percentage error of the temperature change. Now what we had done was we had used a thermometer with the calibration of 0.1 degrees Celsius. So our maximum error of such an apparatus which has an calibration of 0.1 should be 0.05, because this is the part of the reading which our thermometer or the apparatus is not able to read. So maximum error of the thermometer which we have used is 0.05 degrees Celsius. Now the thing is that we had used the thermometer twice to calculate the initial and final temperature. So if we have used our thermometer twice, then our error also has to be twice, so it is multiplied by 2. So if we calculate the percentage error, then the maximum error has to be multiplied by 2, as we have used our apparatus twice, and then we will divide it by the reading which we have obtained with the help of that apparatus. So the reading which we have used for our calculation of our thermometer is 20.1 degrees Celsius, and then we will multiply our answer by 100 because we are calculating our percentage error. So in this case, now our percentage error for our apparatus in this reading is 0.498%. Now I'll note down one point here is that wherever possible, please show your working, because working also has carried the marks in most of the questions. So working has to be shown. So we have seen here that wherever possible we had shown the working, but in the table there was no need of showing the working. So the first part, A part of the question, there was no working needed. Later on the other questions had given the space also for the working, and we need to show the working of each and every calculation. Let's go ahead with the next part. It says that state the effect, if any at all, on the accuracy of the experiment if the spirit burner was allowed to burn for longer, and explain your answer for that. Now here there are two possibilities, but according to what I think is that the accuracy would increase. We need to write it clearly, increase. Now we need to explain our answer also. So the reason has to be given also here, because the percentage error would increase. So we will write because the percentage error, I'm writing in short but we need to write it in full words. Percentage error decreases. That's why our accuracy of the answer would increase. And the reason for this percentage error, which we don't need to explain here, but I'm just for your explanation, your understanding, let me explain why the percentage error decreases. The main point here is that if the bigger our reading is, the bigger part of the calculation we are using, the percentage error will decrease. So if the reading is very, very small, there are more chances of percentage error, because we can see here that in the denominator we have used the reading. So if we want to decrease our percentage error, the reading has to be a bigger one. So to get a bigger reading, we need to carry on our experiment for longer time. So this is the reason that accuracy would increase if we burn our spirit burner for the longer. and this is one part. But the second possibility is that accuracy would decrease. Now you can answer any one. The only part is that the reason given should be correct one according to your answers. If we say accuracy would decrease, then there should be a valid reason, and the reason is being that if we heat the water or the burner for a longer, the heat loss will be more for the experiment. So the enthalpy change calculated would not be accurate. So heat loss is greater. That reason we can write. Because heat loss is greater, enthalpy change of combustion won't be calculated to a greater accuracy. So these are the two reasons. The only thing is that we need to explain any one answer and one reason. Let's go ahead with the next part of the question here. It says that the flame was extinguished but the lid of the spirit burner was not replaced immediately. Now predict how this would affect the value of delta Hc, that is the enthalpy of combustion, and explain your answer. So before predicting the answer, let's first understand that what is going to happen if we don't extinguish the flame immediately with the lid on the spirit burner. Now, if we don't cover the lid on the spirit burner, then there are chances that some ethanol may still evaporate out. Now, if some ethanol has still evaporated out, then the change in the mass which we calculated will be greater, and because of that the moles which we calculate for the ethanol will be greater than the moles of ethanol used. Moles of ethanol will be calculated greater than what it was actually used. So that's what I'm repeating here to explain you the main reason. Now because of that, the delta Hc would be less exothermic. That is, the value which we have obtained will be smaller as the number of moles goes in the denominator. So that's why what we need to understand is that if we don't cover the lid, then delta Hc, that is enthalpy of combustion, would be less exothermic. That should be our answer. And the reason is that the moles of ethanol calculated, moles of ethanol used will be calculated greater than the actual moles of ethanol. So this is how we'll explain our answer, what effect it would have on the value of delta C. So we need to understand and explain it in terms of the value of delta Hc, enthalpy of combustion. So enthalpy of combustion should be specifically mentioned that it would go less exothermic because moles of ethanol calculated used would increase. The next sub question says the value of delta Hc of ethanol under standard condition is minus 1367 kilojoules. Now what we have calculated is much lesser than this. So let's read the next part. It says other than the reaction not being carried out under standard conditions suggest two reasons why the value of the student obtained in C is different from the actual value. Now we know that our value is very less than the actual value. Now what is the reason is that we have not calculated or used up mentioned all the heat used here. So we can say that the heat is lost to the environment. There is a heat loss to the environment or to the surrounding also we can write. So there is an heat loss to the surrounding. So that is one of the reason. Now the second reason that why our answer is different is that there is a combustion going on. So if there is a combustion, there are chances that the combustion is incomplete. So we can also write that the combustion gone was incomplete. So if there is an incomplete combustion, then we cannot calculate all the heat transferred to the water from ethanol burner spirit to the heating up of water. So here second reason is that the combustion was incomplete, or we can say the combustion was incomplete. So whenever an experiment is carried out, we should always understand that there are chances that whatever experiment was carried out will have a different value than the actual theoretical value. So we need to understand the reason. That there are many times in the question paper they have asked the reason, and these are the certain reason we need to keep in mind, which is always considered, that if especially there is an enthalpy question, there is always a heat loss to the surrounding, and if the experiment is incomplete or all the reactants have not undergone the reaction, there may be such reason for the change in the value. So here if we are burning an ethanol for combustion, then the combustion is incomplete. If there is some other reaction, then the reaction was incomplete, or all the reactants didn't turn up into the products. There may be such reasons for the difference in the answer of the practical value and the theoretical value. And then next and the last sub question is that here is asked, it is possible to calculate delta Hc, that is enthalpy of combustion of ethanol, using average bond enthalpies and the chemical equation for the reaction. So with this equation and the bond enthalpies, we can calculate enthalpy of combustion. Using bond enthalpies, the average bond enthalpies, delta Hc of ethanol is 1297, that is minus 1297 kilojoules per mole. Now explain why this value is different from the actual value of enthalpy of combustion of ethanol under standard conditions. Now we have seen that the under standard condition, the average energy was something around 1300, and here with the bond enthalpies it is minus 1297. So why there is a difference in the bond enthalpy average energy, the enthalpy of an combustion calculated with the help of average bond energies or with the help of the Hess cycle, that is the combustion values. So the reason for this difference is that the bond enthalpies of any compound, bond enthalpy of compound is actually different for different compounds. Of here we have taken the average bond enthalpy. So we can write that the bond enthalpy changes or varies according to the compounds, that is according to the compounds. Now I explain you what does this mean. Now if we are consider here as CC bond, or we consider also the CH bond in ethanol. Now this CC bond is going to vary in ethane, or it will change into ethanol also. There is a difference in the CC bond energy of ethane and ethanol. Now here we take an average bond enthalpy of all the different compounds, so there makes a difference. Ethanol will actually have a different bond energy in ethanol. The bond energy of CC in ethane will be different, but here whatever values we consider are the average of all the CC bonds of different compounds. So there makes the main difference. So we don't get the actual value. Or the another reason is that whenever we consider the bond enthalpies, the average bond enthalpies, they are assumed that they are in gas. Average bond enthalpies are assuming the compounds in gas form. The compounds in, I'm writing it in short, but we need to explain it fully, gas form. But here we have taken ethanol in the liquid form, so there also it makes the difference. So that is how the bond enthalpy value of delta Hc is different than the bond enthalpy value, then the average combustion values with the experiment or the reaction. So this is the main part of question 1 of the paper 5-2 of winter 21. Now question 2 will be discussing in our next video.